Physicists, ancient life might have escaped Earth and journeyed to alien stars. A pair of researchers presented a wild new theory in a new paper.
If extraterrestrial life exists somewhere in the universe, how will we find them? And if they're so unlike anything we've seen before, will we even be able to detect them? These are some of the questions that were circulating around the Astrobiology Science Conference last week in Bellevue, Washington. So here's a summary. Basically, we have not yet found aliens, but the good news is that scientists are coming up with new ideas every day on how to detect them. A common theme throughout the conference was that we could look at extreme environments on our own planet to see how life survives there, because similar conditions could exist elsewhere in the universe. For example, scientists are looking at an underwater volcano in Hawaii called the Loihi Seamount, which is made up of these hydrothermal vents, which are openings on the seafloor that pump out heated water and minerals. And the Cassini spacecraft a while ago had found evidence that one of Saturn's moons, Enceladus, also had similar vents. So if life can exist in these weird environments on our own planet, why can't they on Saturn's moon? Last week, NASA announced a new mission. The new Dragonfly spacecraft will explore Titan, which is another one of Saturn's moons, for signs of life. Titan is very similar to an early Earth, and scientists also hope that it can teach us a bit about how life arose on our own planet, something that we're still not sure of. Scientists are also trying to come up with novel signatures that could indicate the presence of life elsewhere in the universe. For example, if life evolved like ours did on our planet, could we detect the technological signals that they're giving off? But these signals don't have to be technological. They could be gases, for example, emitted by tiny organisms. One group thinks that a very toxic gas on our planet called phosphine could actually signal the presence of life elsewhere in the universe. That is because phosphine only becomes toxic when it's mixed with oxygen. So if there's oxygen-free worlds out there, maybe they would happily produce phosphine and we could detect it. It's known that certain life, such as microbes on our planet, produces phosphine in oxygen-free environments, such as in the intestinal tracts of fish and human babies, but it's unknown why in the world they expend so much energy producing it. That was a brief glimpse of some of what I learned at last week's Astrobiology Science Conference. Check back for more stories.
A pair of Harvard astrophysicists have proposed a wild theory of how life might have spread through the universe. Imagine this. Millions or billions of years ago, back when the solar system was more crowded, a giant comet grazed the outer reaches of our atmosphere. It was moving fast, several tens of miles above the Earth's surface, too high to burn up as a fireball, but low enough that the atmosphere slowed it down a little bit. Extremely hardy microbes were floating up there in its path, and some of those bugs survived the collision with the ball of ice. These microbes ended up embedded deep within the comet's porous surface, protected from the radiation of deep space as the comet rocketed away from Earth and eventually out of the solar system entirely. Tens of thousands, maybe millions, of years passed before the comet ended up in another solar system with habitable planets. Eventually, the object crashed into one of those planets, deposited the microbes, a few of them still living, and set up a new outpost for earthly life in the universe. You could call it interstellar panspermia, the seeding of distant star systems with exported life. We have no idea whether this ever actually happened, and there's a mountain of reasons to be skeptical. But in a new paper, Amir Siraj and Avi Loeb, both astrophysicists at Harvard University, argue that at least the first part of this story, the depositing of the microbes into a comet that gets ejected from the solar system, should have happened between 1 and a few dozen times in Earth's history. Siraj told Live Science that although a lot more work needs to be done to back up the finding, it should be taken seriously, and that the paper may have been, if anything, too conservative in its estimate of the number of life-exporting events. While the study's concept may seem far-fetched, humanity is constantly confronted with seeming impossibilities, like Earth going around the Sun, or quantum physics, or bacteria hitching a ride into the galaxy aboard a comet, that turn out to be true, Siraj said. And there's been reason to suspect that it might be possible. A series of experiments using small rockets in the 1970s found colonies of bacteria in the upper atmosphere. Comets really do enter and leave our solar system from time to time, and Siraj and Loeb's calculations show that it's plausible, maybe even likely, this has happened to large comets that graze Earth. Comets are porous, and might actually shield microbes from deadly radiation. Some microbes can survive a remarkably long time in space. That alone is reason for scientists to take the idea seriously, through said, and for researchers from fields like biology to jump in and figure out some of the details. It's a brand new field of science, he told Live Science. However, Stephen Kane, an astrophysicist at the University of California, Riverside, told Live Science that he was deeply skeptical of the suggestion that microbes from Earth might have actually turned up alive on alien planets through some version of this process. The first problem would occur when the comet slammed into the atmosphere, he said. Through and Loeb point out that some bacteria can survive extraordinary accelerations. But the precise mechanism by which the microbes would adhere to the comet is unclear, Kane said, since the aerodynamic forces around the comet might make it impossible for any microbes to reach the surface and work their way deep enough below the surface to be protected from radiation. It's also not clear, he said, whether any microbes would really have been up high in our atmosphere in the first place. Those rocket experiments from the 1970s are old and questionable, he said, and we still don't have a good picture of what the biology of the upper atmosphere really looks like today, let alone hundreds of millions of years ago, when comet encounters were much more common. The biggest question, though, Kane said, is what would happen to the microbes after they landed aboard the comet. It's plausible, he said, that some bacteria might survive decades in space, long enough to reach, say, Mars. But there's little direct evidence that any bacteria might survive the thousands or millions of years necessary to travel to another habitable star system. And that's really the key idea of this paper. Researchers have long suggested that debris from major collisions might blast life around between our solar system's planets and moons. But exporting life to an alien star system likely requires a more specialized scenario. Still, Kane said, the calculations in this study of how precisely a comet might skim through the atmosphere were new to him, and very interesting. Through didn't strongly challenge any of Kane's concerns, but reframed them one by one as opportunities for further study. He wants to know, he said, precisely what the biology of the upper atmosphere looks like, and how comets might react to it. There's reason to think that at least some bacteria might survive super long trips through deep space, he said, based on how robust they are under extreme conditions on Earth and in orbit. But for now, it's time for scientists across fields to jump in and start filling in the gaps, thере said. Don't forget to leave a comment and let us know what you think about this video. Thanks for watching.